So today we will start with a new topic, and we will start looking at the analysis of large graphs. And in particular, we will talk about link analysis and PageRank. So here is the idea. So far, this is how the class fits together, and we are starting with a new topic, with a new set of data, that is the graph data. And in this module of the class, we will look at link analysis methods like PageRank and SIMRank. We will look at community detection, where the idea is that we want to find clusters of nodes in the network. And then we will also look at spam detection, where the idea is that we want to identify nodes that are spam nodes in the graph. So those are the three modules for the graph data section. If we think about graphs, graphs are everywhere in a sense that, for example, social networks, Facebook, Twitter, and things like that can very naturally be represented as graphs. Graphs in a sense of as a set of nodes and a set of edges or connections or intersections between them. Another set of data points that also can be represented as graphs are social media networks. For example, here in this graph, what I'm showing you is an illustration of the structure of the United States blogosphere around presidential election in 2004. And what you see is basically these two clumps in these networks, these two communities, and they basically correspond to the two political parties in the United States system. And you see how this the nodes in one cluster densely link to the other clusters, and there is some number of cross-linking between the two. So there is some amount of polarization in a sense. Another set of data that can naturally be represented as networks are the networks of information. So for example, in this case, what we are seeing here is a map of science. So here every node is a different journal, and or a different conference, and now the edges between these journals or publication venues mean that one journal is citing the other journal. So based on this citation network between journals, we can basically visualize how different disciplines of science and subfields of science, how they are relating to each other. Of course, internet is another case where that can be studied as a graph. So here we have computers or routers talking to each other, and again, this can be represented as a dynamic network of nodes, which represent computers or routers, and then let's say physical links or between these machines, and those are the edges of the network. Of course, kind of the technological networks are also the oldest example of graphs people have been studying. So for example, the field of graph theory goes back to 1700s when Euler posed this problem about the 7 bridges of Königsberg, where the idea is that we want to cross at some point and travel each bridge only once. And the question is, can that be done? And this can be formulated as a graph problem. And the examples of other technological networks, for example, are power grids, road networks, water distribution networks, and so on. And it's important for us to understand the structure of these networks to detect failures, to detect disease outbreaks or contaminations, and so on. Another example of a big part of kind of networks is the web, right? So web itself can be represented as a graph. And what we will do today, we will kind of focus on the structure of the web graph, and we will develop methods that allow us to learn something about the pages on the web. So the first question is, how do we represent web as a graph? We will represent web as a directed graph. So in our graph, nodes will correspond to web pages. So every web page will be a node in this graph. And now we will have directed links between these web pages that correspond to hyperlinks. Right? So if I have my example here, I have a set of 4 web pages, and now these web pages contain hyperlinks. So in this case, a particular web page points to another page via a hyperlink. So we can use now these hyperlink relationships to create a network. Right? So here is a small example. If I show you a bigger example, you could think of the university website as a big giant graph of web pages citing or referring to each other via the use of hyperlinks. Right? So we just represented the web as this network. The question is, how is the web organized? the way people tried to approach organizing the web was to naturally curated by humans. So for example, Yahoo, back in 1996, their original idea was to take all the web pages on the web and manually categorize them into a set of categories. So for example, here I have a screenshot of the web page, and you see that the top category was, for example, arts, there was business, there was education, and each of these categories had further subcategories. So the idea was to take every web page and categorize it into this giant hierarchy. Of course, time showed that the web was growing far too quickly, so this did not scale. So the next way how to organize the web and how to kind of find things on the web is the web search. And this is what we use today. And what is interesting in terms of the web search is that there is rich literature, in particular the field of information retrieval, that covers the problem of how do we find a document in a large set of documents, right? So in our case of the web, we can think of every web page as a document. The whole web is one giant corpus of documents, and our goal is to find a relevant document to a given query in this huge set. However, traditionally, the information retrieval field was interested in finding these documents in relatively small collections of trusted documents. So for example, like newspaper collections or patent collections and so on. However, the web is very different. The difference is first that the web is huge. And the second thing is that web is full of untrusted documents, random things, spam, unrelated things, and so on. So the big question on the web is which web pages on the web should we trust? Which web pages are kind of legitimate and which are fake and irrelevant? And this is what we will be looking at today, is how do we identify a set of relevant or trustworthy web pages in this huge web graph. So when you are doing the web search, there are two challenges, right? So as I mentioned, the first challenge is who do we trust on the web, right? How do we know which web pages are legitimate and which web pages are, for example, spam or somehow fabricated on the web? The idea here is that we will use the structure of the link web graph to understand these things. So the idea is kind of that trustworthy web pages will link to each other, and we will build on this idea to exploit it to be able to identify the PageRank algorithm. And then the other problem that happens on the web is that sometimes queries can be rather ambiguous. For example, you can ask, what is the best answer to a query newspaper? And there is really kind of no good answer to this query. And the goal here, if we want to identify all the good newspapers on the web, is to again look at the web structure of the structure of the web graph in order to identify the set of pages or a set of newspapers that are linking to each other, and again get the result out of the structure of the web graph. So these are the two challenges we will address in today's lecture. The way we can address both of these challenges is to basically realize that the web as a graph has very rich structure. So one thing that we can do is we can try to think of this problem abstractly as a way to rank nodes of a big graph. So basically, we would like to compute a score or an importance score of every node in this web graph. And the idea is that some nodes will collect lots of links, so they will have high importance, and some other nodes will have a small number of links or links from untrusted sources, so they will have low importance. So that's the thing we want to compute. So in order to compute the importances of the nodes in a graph, there are several approaches to this. Broadly, these approaches are called link analysis, because we are analyzing the links of the web graph to compute an importance score of a node in a graph. So the first approach we will look at, it's called PageRank. And this is really the algorithm that was invented and that behind the initial implementation of the Google search engine. Then we will look at also at another algorithm that is called hubs and authorities. Here the idea is that we have two types of web pages in a web graph. We have the web pages that are called hubs, and we have web pages that are kind of called authorities, that are good authorities for given topics. And then we will look at some extensions of these algorithms, first in terms of topic-specific, or what is also called as personalized PageRank. And we will also use these ideas and apply them to web spam detection. where basically spammers may want to manipulate the structure of the web graph in such a way to make some web pages to seem important even though they are not. So basically boost importance of some of the web pages.